think that you've already at least heard the word with Mr. Caskey before, yes? Yes, and maybe talk about it a little bit? Okay. When we're talking about equivalent, that word equivalent, because we know what fractions are. It's that word equivalent that we don't quite know. If we look at the word equivalent, what does that word look like? Because it looks like a word that I already know. What does that word look like? Right? What does it look like?
Equations.
Kind of looks like equations. What else does it look like? Lauren?
The beginning of E is part of equal.
It is part of equal. Equivalent kind of sounds like equal. Yeah. Mateo, what were you thinking?
Can I flip the level?
Not right now. Bailey? You're thinking equal to? Yeah. So equivalent, please go ahead and put this in your notebook, is a very similar definition to equal. And we've talked about equal before as not being the exact same thing, but having the same value. So the word equivalent is very similar to equal. It means two things that are worth the same amount, but are in a different form. Maybe they look a little different.
Yeah. Did we do an equivalent fraction like this morning?
But yes, Mateo, you're correct. So some examples of things that are worth the same but look different might be 4 quarters are equal to what? Peter, the only one that has ever used 4 quarters before. Holy moly, Peter, you're going to be a millionaire. You already know what 4 quarters are. That's going to call you quarters. Peter, what is equivalent to 4 quarters?
1 quarter.
Not 1 quarter,
One whole.
one whole
quarter.
Nope. What? Maybe not a millionaire. 1 whole, Matthew, help him out.
$1.
1 whole dollar.
I'm a millionaire. No, you don't.
Do 4 quarters and a dollar bill look exactly the same?
No.
Are they the exact same thing?
Yes.
No. They don't look exactly the same. So I would say that they're the exact same thing, but they're worth the same. They look a little different, but they're still worth the same. The vending machine doesn't care if you pay with a dollar bill, if you pay with 4 quarters. Even though they look different, they're worth the same. Can you think of other things that are examples of equivalent? What are you thinking of? We talked about 1/2. What was the example we did this morning, Mateo?
The 4/8,
Mm-hmm.
also known as 1/2.
Also known as 1/2. I like how you said that. Also known as. Can you think of an example, not necessarily of fractions, but kind of in real life, of 2 things that are worth the same, but maybe look different? Please?
$100 bill looks different from $101 bills.
Sure. Let's make that a little bit smaller. What if I just had 1? Maybe not.
It's probably loading.
Oh. Let's say I had 1/10, and how about just 7 1s? That might look different than if I just had the number 17. That might look a little different. Is it still worth the same? Yeah, we would say those 2 things are equivalent. Do you think another thing that might be worth the same but in a different form? Alyssa, what are you thinking?
instance, like the problem we had this morning, with the conflict of interest.
Okay, so you're talking about one whole something being equal to, okay, so if we had a pizza maybe cut like this, that would still be equal to a pizza cut like that. The value is still the same even though they look a little different, cut up a little different. Sure. Sure. Jake, what do you think of? When that, what would be another way of saying that? 20 plus 5, or we would just say 25. So make sure you have a couple of examples of equivalency. That's very similar to what we already know about the equal sign. We know if we go back to when we did it with multiplication, we know that 3 times 2 is still going to be worth the same amount, even though it looks a little different, as 2 times 3. Those equations are not exactly the same. They're not exactly the same, but they're worth the same amount, even though they're slightly different. Do you have a question? Hang on. Do you have a question? Give me the question.
Doesn't equivalent mean just basically the same thing in different ways?
So we don't say the same thing, because if someone is exactly the same thing, they look exactly, they are exactly, they're the exact, it's like a copy.
Miller,
Yes? Yes?
attendance, please.
Yep, I'll give it to you, sorry.
Thank you.
We say that it's the same value. It's worth the same. We talked about it too with 2 tons is worth the exact same amount of weight as 1 elephant. Is 1 elephant the exact same thing as 2 tons? No, but they are worth the same. You see what I'm saying? So we say that they have the same value.
So yesterday when we were into looking at our fractions,
Mm-hmm.
we had to use a hat and we had to switch.
Mm-hmm. Yep, they were the same value. You already know equivalent fractions, and you kind of proved that again today. We know them as fraction matches. Right? We've done fraction matches. That is equivalent fractions. So you've been doing equivalent fractions already. Those matches, the correct answer is equivalent fractions. Go ahead and take out your fraction strips. Excuse me. And I want you to make as many fraction matches, or as you could have learned, equivalent fractions as you can to 1/2. So that means they have to match 1/2.
But we don't have to do 1/2.
Yes, you have other pieces though. Alright, what are some fraction matches, or as we know now, equivalent fractions that you make? Remember, we can tell that they are worth the same value if they take up the same amount of space. So if this is 1/2, then my fraction matches, when I line them up below 1/2, have to take up the same amount of space. They can't be too long or too short. What was something that matched or was equivalent to 1/2? What did you find? Jake, what's one that you found?
4 1/8.
What was it?
4 1/8.
4 1/8, or we would say just 4/8. Yep, 4 1/8. We would just say 4/8. So when you lined it up, Jake, did it look? Ooh, ignore that craziness. Did it look something like this? Notice that they are the exact same length. When I line up my 4 1/8, it's exactly the same amount of space as my 1/2. Perfect. So I have 1/2 is equivalent to, I like how Jake said 4/1/8, or also known as 4/8. What's another match that we found? Remember, it has to be the same fraction. So you can't have like mixed fractions in there. Lauren, what's another one that you found?
2 1/4 and 1 1/2.
Okay. How would we say 2 1/4? 2/4. Yeah. So Lauren found that 1/2 was also equal to 2/4. So it looks something like this, Lauren.
Yes.
I haven't even drawn it yet. You already think you have a lot of confidence in me. Does it look like this, Lauren?
Yes.
I like it. I like it. What else did you find? Lene, what equivalent fraction did you find? 3/6.
Oh.
Interesting. 3/6 is equivalent to what, Lene? Beautiful. Anything else? Anything else? Remember, it has to be the same length, so it's got to be the same fraction. Lee, did you find another one?
No, but I noticed denominator.
Uh-huh.
It's so if you're skip counting,
Interesting. And you noticed something too. What did you notice when we made these fraction matches?
that all the denominators are equal.
Are not equal,
No.
even. So Lee and Aiden were noticing something. What else are you noticing? Lee noticed that they're skip counting by 2s. Aiden noticed that all the denominators were even. So Diana, what are you noticing? You can't use thirds to make 1/2. You can't. Yep, you can't use it to make it equal. What's that? 1/2. Sure. 1/2 is equal to 1/2. Yeah. So what they're noticing, which I think is a great observation, what they're noticing is that the denominator, when we're trying to find something that's equal to 1/2, also needs to be an even number. So are thirds going to work? 3 in the denominators, 3 an even number? No. Try 1/3. Is that going to be equal to 1/2? No. What do you think about if you had fifths? I know you don't, but knowing what we know, are fifths going to work? No. Probably not. Probably not. Kayla, what's that?
Couldn't why it's kind of what Lee said,
Uh-huh.
but what I'm noticing is the even numbers and the odd numbers, they don't like each other, so sometimes the odd numbers don't fit. It's because they're too big. It's because the smaller the number, the bigger it gets. And so I'm thinking it's because of that. It's because if I would put a 3 down and then put another 3 down, it'd only be a 6. It's because what I'm trying to say is that I'm thinking that the even and odd numbers don't like each other. It's because they're different.
Alright, so we're going to do a think, pair, share. What that means is you're going to think about it in your head first, then you're going to put it up and talk about it with a partner, and then you're going to talk to me. Alright, so we're going to think about this problem. I have 2 visual bar models up there. I want you to think only in your head, not play with your fraction pieces. So you should not be touching your fraction pieces at all unless you would like them to be gone. You're thinking in your head, how are these two models alike? And then how are they different? So you're just thinking in your head for a moment. Then you're going to have a chance to talk to the neighbor about it. So take 2 minutes. Please get your hands out of your shirt. Think, what's similar and what's different about these two visual bar models? Alright, let's start with how are these two models, let's start with different. So we have similar. Extra bonus dolphin dollar if you could say it with and compare contrast first. How are these models different? Different. Lene, go for it.
They're different because one has lines and one has. They're different because one has lines and one doesn't.
They both have lines.
One has lines on the bottom and the top, but one doesn't.
They both have lines on the bottom and top. Mitchell, how are these different?
The first one has only 6 squares, and the other one only has 2.
Okay. So can we say the one is broken into
The one is broken into 6.
into
and the
6?
other is broken into 2.
Let's say let's just draw it out.
And the other is broken into 2.
One's broken into 6, one is broken into halves. Beautiful. Then use a contrast word. You said and not a contrast word, but that's okay. I like the thought. I dig it. Natalie?
Fraction of the one on the right is 1/2, but on the other hand, the fraction of the one on the left is 6.
Okay, so if we're talking about the blue, on one fraction is 1/2. I like that she actually threw in 2 of those. She said, but on the other hand, both of those are contrast words. One, let me make it a new bullet. So the blue on the fraction on the right, as Natalie said, is worth 1/2. The blue on the other fraction is worth 3/6. Alright, let's scoot over to how these are similar, how they are alike. Very confused by that. Susanna.
Both were really rectangles.
Both have red and blue shaded parts. They are both rectangles. That's true. That's good. I like that you used the compare word both. Kate, how are they similar?
They both are similar because they both equal. Because if you split that one, they both look the same.
They don't look the same, but they are equivalent. They are not completely the same thing. They are worth the same, meaning the blue parts. Please stop jumping up and down. They would be equivalent. Good job using similar to Kate. Anything else? Eleanor?
Both have 1/2 shaded,
however you want to look at it. They are equivalent. Riley?
We just had horizontal lines.
Sure. Savannah?
The one on the left equals one whole. And also,
If they were all shaded the same color, yes. Sure. Sure. So these fractions are equivalent. If we look at just the blue parts, we have 3/6 worth the same as 1/2. That's very similar to the think about this that we did this morning. All right. We are going to play a game. So go ahead, put your pencil in your notebook and close your notebook. You might have to look back at it, so don't want you to put it away, but just close it and kind of push it to the corner of your desk. So we are going to play a new game. We are not going to play Cover the Hole. This is a new game called Uncover the Hole. So if you'd like to play, I suggest that you turn your voice off. Put all your fraction pieces in a pile. Make sure your math kit's not on your desk. You don't need that on your desk. Now when we start Cover the Hole, all we need is the whole piece out. Today, you're going to need your whole piece and your 2 1/2 pieces. So your game board, when you get set up, is going to have your 1 whole, and then below that, you're going to make your 1/2 pieces line up.
oh, so we could try to get 2 1/2.
Please wait for me to go over how to do the game. Now this game takes a little more strategy. When you're doing Cover the Hole, it's a lot of luck. Can I roll the correct fraction? Okay? With Uncover the Hole, there's some strategy. The point of the game is to pull off all the pieces and be left with just the whole. Okay? So when it's your turn, you have 2 options. You can roll the dice. Whatever fraction you get, that's the piece you can take off. Or you can trade your pieces. Okay? If I wanted to trade for something that's worth the same amount as 1/2, what could I put in place of it? What can I put in place of my 1/2? So maybe when it's my turn, I decide, I don't really want to put 1/2 up there. I'm going to take my 1/2 piece off. And instead of having a 1/2, I'm going to put, what color are those? Yellow?
Yeah. Oh no.
No, that's a good way to not get to play. So now I have my 1/4 and my 1/4. You can only trade if it's worth the same. And when you trade, you don't get to roll. So you have 2 options when it's your turn. You can either roll or you can trade. Okay? You cannot trade pieces that are not of the same denominator. So like I can't trade out my 1/2 for a 1/3 and a 1/6. I can't do that. It has to be all the same. Okay? Eva, do you have a question? Alright, Lee, rock, paper, scissors with Caleb. We're going to do boys versus girls on the first one. Alright, Lee goes first. Now, oh, Kaylin goes first. Now, all of your boards, whether you're on the girls' team or the boys' team for right now, is going to be 2 1/2. And I'm going to call one boy when it's the boys' turn, and one girl when it's the girls' turn, to tell me what decision they're going to make, whether they're going to trade or they are going to roll. Does that make sense? Yeah. Alright, so girls go first. Kaylin, are we going to trade or are we going to roll?
Trade.
Trade. What are we going to trade?
Six.
Okay, so you're going to trade a 1/2 for... Alright, ladies, take out 1 1/2 and trade it for 3 6 because they are worth the same. So ladies, your board, what color is 6?
Blue.
No, what's that? Ladies, your board should look like this. Okay? Alright, Lee, are you gonna roll? Or are you gonna trade? Roll. Peter, what do you get?
1 4.
Which is really?
1.
Gentlemen, do you have 1/8 on your board?
No.
So can you do anything?
No.
No. Alright, ladies. Okay, are we gonna roll or are we gonna trade? Trade, what are we gonna trade? Alright, so ladies, take off your other 1/2. You're gonna trade it for 2 4.